Okay, so our last section of our notes for this particular section here, 5.2a, will be special cases. There are two particular equations that you have to be able to recognize that have a special look to them. They're not just diagonal this way or that way. They're special. If I was to give you these two equations, look at letter C there, and I said I wanted you to graph these two equations. How would you handle that? Well, I know some of you would just skip it and not even try to do the problem. But if you look at what's going on, is we've gone from that two variable equation to just one variable. So when we talk about special cases, that should be the first thing that alarms you, is there's no longer x and y in one equation. You're down to just an x or just a y. What these equations are telling you is that when y is equal to 2, x can be anything it wants to be. Y will always equal 2. All right? On your y-axis, you would plot at 2. And then x can be anything it wants to the left and the right. For x to equal -4, that means that your y value can be anything, any value, any number, big or small, positive, negative, that it wants to be. But this x is stuck at -4. So it moves over to the left 4, and it sits right there and stays there. So that's what these two values, and I'm saying -4 and +2, they could be any numbers. But when you see your equations look like this, where only one variable is showing, that means that that one variable stays, and the other variable that's missing can be any number that it wants to be on that line. When we talk about equations that look like this, these equations are your horizontal and vertical lines. Okay, so these equations are your horizontal and vertical lines. So I'm pretty sure that you will be able to recognize that your special cases are horizontal and vertical lines. The question is, will you be able to determine which equation is horizontal and which equation is vertical? Well, here's what you have to remember, and this may be something you want to put a big star, highlight, box, or whatever in your notes. Your horizontal line equations will always be y equals a number. Any number. Big, small, fraction, decimal, square root, positive, negative. It's going to be y equals a number. And that means that on your coordinate plane, whatever that number is going to sit right on the y-axis and stay there. It's going to stay put. And that x can just go anywhere it wants to the left, to the right. That's how you create that horizontal line. That y value is just sitting. Your vertical will always be x equals any number. Big, small, positive, negative, fraction, decimal, exponent, whatever. That's what it's going to be. And what that is saying is, that equation is saying, if I have my coordinate plane, if I have a value of x, that value is just going to sit right there for my x, not move to the left, not move to the right, but my y value is going crazy up and down. It can go anywhere it wants to, but it's going to stay right at x equals 5, 10, 20, 30,000, whatever it is. That coordinate, that number will stay the same. That's how you create a vertical line. So when we talk about sketching the equations here and here, if I want to graph y equals 2, that means that that 2 tells me to go up 2 units on my y-axis and sit down. Y equals 2 is a horizontal line. So I just go to the left and the right, and that's my horizontal line for that equation. X equals -4. That means on my coordinate plane, I go over 4 spaces to the left, and then I stay there. My x is equal to -4 all day long. But my y values can go anywhere they want. Up, down. There's my vertical line. So pay attention to these special cases. Try your best not to get them mixed up. You have some homework for this section. I'm going to ask that you do half of the problems. I can't remember how many they are. There may be 15, 16, 20. I want you to do half of the problems before you walk into class. Half. So I'm going to write here, homework. You've got it. I passed it out to you. Pull out your homework. Do half the problems. You just spent 20 minutes doing these videos. Now take another 20 minutes and do half the problems and walk into class and have an idea of what you're talking about. I'll see you there.